Hey everyone, thanks for joining. Today I'm going to be doing a long form YouTube video on creating a full stack web app which uses LangChain and an Next.js front end for indexing, performing QA, taking notes, and overall just an easier interface for understanding papers from Arxiv. If you're not already familiar with Arxiv, it's a website by Cornell. And essentially it's a place where researchers can publish their papers. And if you go to, for example, this Arxiv URL, you can click download PDF, and then you can easily get access to their paper in a PDF format. So this app is, at a high level, what it's going to do is you're going to have a front end. You can submit a paper URL, and then the back end is going to parse that paper. It's going to split up into chunks. It's going to hit GPT-4. Thanks to their new 128K context window, we can confidently fit the entire paper, no matter what paper it is, into that context window. We're going to have GPT-4 take notes on that paper, and we're going to then return those notes along with a set of questions, which it's essentially prompting our user to say, hey, you can also ask questions about these different parts of the paper. And then from there, the user is going to be able to say, what is XYZ talking about in this paper? And it'll go back to our server. Our server will then we're going to embed the paper, split it into chunks. Using that, it'll be able to look up context and answer your questions based on the context in that paper, so you can chat with your paper and understand it a little bit easier than having to go through and read the entire paper. Maybe instead of having to read all 18 pages like in this paper, you might only end up reading 4 or 5 pages total, and you get a pretty good understanding of the paper. So to start, we're going to have a TypeScript monorepo. I've already created this boilerplate. Essentially what it has is a web directory and an API directory. And the web is going to be a Next.js app. We will get to that later. And the API is just a simple TypeScript app. We're going to use Express.js to make it, to be able to turn into an API. You can clone this from my GitHub. I'll have this template set up so you can clone there and start from where I'm starting at. So API source directory, we're going to have an index file, and to start off, we're going to create our main function. This function is going to take in 3 things: the paper URL, the name of the paper, and that's just for like UI, so you can on the website you can see what the name of this paper is. You're doing QA over, and then a third optional argument, pages to delete. This is important because if we go back to this paper, we see it's 18 pages. However, as we scroll down on page 10 through 12, so 3 pages, there are references, citations, and these are full of text we don't really care about, and oftentimes they have lots of keywords which can hinder our semantic search capabilities when we then go and try and perform RAG in this paper. So this pages to delete optional argument is going to be the user can specify which pages they want to remove, and then we won't take notes on that paper. We won't send it to GPT. We won't embed that or touch them at all, so that we can have a cleaner embedding. So let's start by making an async function main. We're going to take in 3 args, so paper, URL, name, and pages to delete. So this is going to be a paper URL at a string. Thank you, Copilot. Name, string, pages to delete is number, but we want the number array. We want this to be optional. And then the first step for this function is actually loading the paper from the URL. So we're going to use Axios. We're going to load it as a buffer and return it. And that way, it's an easy way to actually load this PDF and then be able to interact with it. So let's go ahead and create a helper function. We'll call it function load PDF from URL. So URL string, and then we actually don't want that Copilot. Let's type the response promise of buffer. Nice. And here we're going to have to import Axios. So import Axios from Axios and declare our, that is what we want. Thanks, Copilot. Yeah, so what this is doing is it's making an HTTP request to the URL we specified, and it's defining the return type as an array buffer. This is we're going to want to wrap this in a buffer.from though, just to make sure we actually do get our buffer return. And then inside of our main function, we can do a quick check if paper.url.ends with bang is false. PDF, we're going to want to throw because that will not be the valid type. So throw new error, not a valid PDF. All right, and then we can call our function. So it's going to be const PDF as buffer equals await, load PF URL, paper URL. So what it's going to do is we're going to be able to pass in our paper URL, and it's going to load that as a buffer. And the next step is we're going to want to pass that through to Unstructured, which is a tool with or it's a component that LangChain offers, which will allow us to break this paper down into smaller chunks, more manageable chunks that we can embed. We can then convert that back to a string to send to GPT. And it's overall just a really great way of dealing with unstructured data. They support most data types, PDF, HTML pages. They kind of do it all, and they've got some magic that happens in the background, which is able to parse this PDF and break it down to pieces like a header or a body description or an image or a table, whatnot, and it makes it really easy to deal with these unstructured data formats. Actually, for this, I made a mistake. Since we're specifying the return type as array buffer, we don't need to wrap it in buffer.from, and instead we can just do return response.data. And as you can see, our TypeScript is not complaining about that, and that's because it's any typed. But we know that since we're using this response type, it will be the right response type. So after we've done this, we're going to want to go through and delete the pages first if a user has specified pages to delete. And we want to do this before we actually use Unstructured to parse the PDF, because we don't want to be parsing pages we don't care about. So let's do a quick check to see if pages to delete is true and pages to delete length is greater than 0. And if this is the case, we're going to want to call our pages to delete function. So let's go specify that up here. Step 1, we're going to be using a library called pdflib and their PDF document class to actually load and handle deleting the pages. So let's define a new function, async function delete pages, and this is going to take in the PDF as a buffer and the pages to delete as an array of numbers. Let's use this. So what they're doing here, they are loading the PDF and awaiting that, which is what we want. But this is not going to work. What we want to do instead is iterate over each page to delete. So we need a counter for the number of pages to offset by, and this is because once we remove a page, the total number of pages in that PDF is going to change. So we need to add 1 to that number offset by. So let num to offset by, and we'll start that as 1. And then for const page number of pages to delete, pdf-doc.remove page number minus number offset by, and then plus plus, and that looks right. And then what we're doing here is we're saving the new PDF and returning it. This is going to be our unit 8 array, but we want to return it as a buffer again to match our previous type. So we are going to have to wrap this in a buffer.from to convert this back to a buffer. So now we can go down here, and if a user has specified they want to delete some pages, then we can delete them here. So we're going to do wait pages delete pages, PDF as a buffer, and pages to delete. And then we're also going to change this to not be a constant, so we can reassign the PDF value there. Okay, so the next step is actually using Unstructured to chunk and parse our PDF. So we're going to define a new function, call it async. Let's see, convert PDF to documents. And the documents is referring to LangChain's document type. It's the type we use for specifying documents that we then embed, and that type is used broadly across the LangChain library, so we want everything to be in that type. So we're going to specify, one argument, PDF buffer, but our return type is going to be a little bit different. We're going to want to return an array of documents. And this usually does not recognize that documents needs to be a type. So let's go ahead and import it from LangChain. So import document, that's not right, from LangChain / document. And then we have the proper document type, and our TypeScript will be happy with this. And that is obviously not right. So async function, convert PDF to documents. The first step, unstructured requires an API key, so we'll have a check for that. If process.end.unstructured API key is false, not at, we want to do is false, and we want to throw a new error. No API key set. And we'll change that to missing unstructured API key. Make it a little bit more specific. And then the one thing with unstructured, and this is also why we had to do it in the back end, and we couldn't, or as like a separate API service running on Node and not on the edge, is that unstructured with LangChain requires a file path to read from. And if we're doing that on the edge, then we can't actually use the Node file system to write files. So the first step is we're going to get a random name to set our file name as, and that's to avoid file name collisions. So const random name equals, yep, that looks pretty good. And the next step is to actually write a file with this random name and our PDF. So let's go ahead and import. We're going to have to add 2 imports. So import write file, and then also unlink from fs promises, which is going to allow us to delete our file when we're finished. So unlink from fs promises, and we want to use the the promises library because we're using Node's async. So once we've imported these, we can go back down to our function and we can call await write file, and then the PDF path, which is going to be, let's set that as pdfs/randomname.pdf, and then we can actually pass in our PDF, and for good measure, let's set binary as the type. Once that's set, we can call our unstructured loader. So we're going to, step 1, we're going to be importing unstructured, import unstructured loader from LangChain document loaders. So down here, we can define our loader function. So const loader equals new unstructured loader. We're going to want to pass in our path to the file, which is going to be the same as this. So PDF path, and then also some options. So our API key, which is that, and then also we want our strategy to be high res. Strategy is not that, we want it to be high res. All right, so once we've defined we've instantiated our unstructured loader class, we can actually go and load these documents. And what that's going to do is it's going to look at our PDF, it's going to chunk it. I think I mentioned this earlier. Unstructured, they do some cool things around identifying what parts of a PDF are the like the title or like a paragraph body, and it chunks it into these nice parts, and also adds metadata, identifying which paragraph relates to which title. So we're going to load these documents. We'll define a documents loader, and thank you Copilot. That's how we do it. So we call the load method, and this is going to take a second, and it's going to load all of our documents and return it to this variable. And as we can see, it's the nice LangChain document type, and then that is what goes inside. And then once we've loaded our documents, we can do exactly what Copilot suggested, which is unlink or delete the file and return documents. So let's go over this one more time. What we're doing is we're passing in the PDF as a buffer, and we're verifying our unstructured API key is there. We're creating random name to prevent file conflicts, if you are running this simultaneously, you don't want to just have like a static name, because two files could try and write at the same place, and that would mess everything up. And then we write the file with our random name as a PDF, passing in our PDF buffer, and defining it as binary type. And then we instantiate our new unstructured loader class, give it the name. We want to give it the API key and our strategy, and that gets returned to this loader variable. And then we can load our documents, delete the file, and return our documents. So if we go back down to our main function, we can do const documents equals await, convert PDF to documents, PDF as a buffer. All right, so once we've gotten to this point, we've done a few things. We've loaded our PDF as a buffer. We've deleted pages if we specify that, and then we've converted our PDF to LangChain's document type. And the next step here, we're going to want to actually verify this all works. So let's console log our documents, and then this is probably going to be pretty large logs. So at the end, we're going to log length, so we can see how many documents were loaded, and that'll give us a rough idea as to if our thing worked or not. So we'll call this main function, and we'll go back to Chrome and use this PDF that I specified here. So PDF URL, we'll set that to this, or paper URL rather, and then we'll make the name. We're not doing anything in that right now, so name can be test. And then we'll go to our terminal. If we bring over our terminal, and then we are in our YouTube videos, archive paper rag, and we can call in this boilerplate repo that you can clone from my GitHub. I define a few scripts in the root, which uses turbo repo and allows us to, I'll just show you. It allows us to start our API start command from root. So start API is going to use yarn turbo run start, and then filter by our API project. So we can just run yarn start, yarn start API, and that's actually going to start our API. So while this loads, okay, so we got an error. What is this saying? No such file or directory open, PDF / the name of our PDF. Let's go and let's see if it created our PDF. It does not look like it. So what we'll do here instead is we'll go into our, there was no directory, which makes sense, so it couldn't actually write the file. So let's navigate into API, make directory, what do we name it? PDFs, and then I bet we can just run yarn start since we're in API. If we do this now, it will work. And Unstructured does take a second since it's performing a lot of computations. So I'm going to pause this and come back when this start command is finished. All right, so it's been a little while, and as you can see, nothing's happened. So I'm going to cancel this, and we're going to perform a little bit of debugging. So to start, this should work. Let's just add some console logs to see how far we get after first if, and then we can do after loader, and then that shouldn't get called because we're not passing in an array. So we'll call after docs. And I'm guessing that the problem is going to be in here. So let's add some more functions. We know, so we know we were able to get to write file last time because we got the error that the PDFs directory didn't exist. And if we look in here, it did write a PDF, and it is what we want. So we can actually go down and delete these two because we know it made it there, but it's not making it to after documents. So let's make sure we're able to actually instantiate our class properly. So before load, and the file wasn't deleted, so it's probably happening here after load. And I bet if we go and we rerun, we're going to see before load and not after load. And if we look quickly, as we can see, it's created a new PDF, but no logs yet, which is interesting. I'm going to pause this, and if we do get to some logs, then I will resume. All right, quick resume. I realized we didn't add a log before here because we know we're writing, but we're not sure if we're able to get past here. So if we add that log, go back to our terminal, we see nothing's logged yet, and we rerun, then let's verify, yep, it's written the third one, but it's, here we go, after write and before load. So after write, it's able to instantiate the class and before load, which means that this is taking a very long time for some reason. Let's see. What I would do now is I would go to the Unstructured site, or I'll go to the LangChain site and look up Unstructured and see if they say we're missing anything. Okay, so looks like we need to actually add this Docker container. Let's see if that works. Let's create a new terminal window and just paste in what they gave us. That makes sense. Don't have the image locally, so it's going to pull it in. And after this is done downloading, we can resume and see if that fixed our issue. Alrighty, we're back. So the Docker container finished pulling, and if we open up orb stack, which is my Docker desktop UI, we can see that Unstructured is running. So now if we rerun this, and we hope and pray, okay, after write, before load, this should take a second, just because I know that this isn't instant, and we will come back when this completes. All right, and we're back. That did take a while, but we can see that after 130 seconds, it generated a bunch of documents, and we got 199 of them, which seems about right for this size and for 18 pages. So if we quickly look through here, we can see that, for example, this one, it's the page content is this snippet, and the category is narrative text. And this is kind of what we care about. The category, parent ID, this is a title, acknowledgements, which makes sense. So you can see that Unstructured is going in, looking at this PDF, and they're not just splitting it by text size or by page, but they're actually looking at the elements of the PDF and chunking it that way. And this will be helpful when we actually embed our documents. The next step is going to be actually generating the notes based on this text. So let's create a new function. We'll call it generate notes. Async function generate notes, and this is going to take in that PDF buffer, or sorry, it's going to take in our documents, array of documents, and the response is going to be a string. Actually, no, we'll probably want to have this be an OpenAI function call, which means we're going to have a structure response, and we'll write that type a little later. So the first step, these documents, we can't actually pass them to OpenAI, so we got to convert them to a string. But luckily, OpenAI has, or it's not OpenAI, LangChain has a nice helper function. It's called format documents as string. And essentially, that is not the right path. It's from utils documents. Util / document. And essentially what this does is it allows us to be able to, okay, so const documents as string equals this, and then we can just pass in our array of documents, and this document type contains this field called page content. And if we look at our log, we can see that page content contains the content that we want. So this format documents as string function essentially just maps over documents, and it joins them all, and joins them with a new line and returns a string. And the next step, so once we do this, we're going to have all of our full PDF as a text, and then we're going to want to define our model. So const model equals new chat OpenAI, and let's import that from LangChain. Okay, and we can't use the default OpenAI model from LangChain because model name, because we want to make sure we're getting that new 128K context. So it's going to be GPT-4 preview 11.06 or GPT-4 11.06 preview. GPT-4 11.06 preview. And this is not going to be the vision model that would we need to specify vision, but it is going to be GPT-4 Turbo. It's going to have a big context, and it's going to be their quickest and smartest model. And then we're going to want to set temperature to be 0.0. We don't really want GPT, being creative. We want it to look at the documents that we gave it and take notes on that. And then next, we're going to want to define, we're going to want to attach our function to it. So we'll make a new function called const model with tool equals model dot bind. And this is a method that our at LangChain, we have this concept called runnables, and you can bind certain things to different runnables. So here we can bind a list of tools. Right now we haven't defined our tools, so we'll give it an empty array. But once we define our tools, we'll pass in our tool there with the OpenAI spec, and that gives our model access to use or to respond in a way which we can then use that tool. And for this tool, it's kind of a complex schema, so I'm not going to type it all out. I have it here. I can copy paste, but we're going to want to put this into an extra. We'll call it a prompts file. So we create a new prompts file, and then we copy and paste this in. And to go over what this is doing, let's import this type. Okay, so essentially what this is doing is it's defining a new client or chat completion tool as the type. It's going to be a function, and then the function is going to have a name of format notes, small description, format the notes response, object, and the different properties are going to be one array with the key notes, and then inside that array we're going to have properties of note, which is the actual note that it took, and the page number. This can be the page number that the note came from, and this is going to be required because they're both inside of notes, which we defined as being required. So using this, we can then import it and pass it through. So now we have our model with a tool bound to it, and as we can see, it's also a runnable now. And because it's a runnable, we can define a chain using the runnable pipe method. So const chain equals, first we need to actually define our prompt. And this is also going to be kind of long, so I'm going to copy and paste it, but we can go over what it's doing. So it's our note prompt. We're going to wrap it in a chat prompt template, which is going to give it that chat prompt template type, which will allow us to pipe it through. So our note prompt, let's import it, and then we're going to pipe that to our model. And then after this, we will pipe in an output parser, but that's not defined yet. So essentially what this is doing is it's taking our prompt, when we call invoke on our chain, so const response equals wait chain dot invoke, and then we're going to pass in arguments here. And invoke is essentially going to pass in these arguments to our prompt. In our prompt, we've defined one input argument as the paper, and that's going to format this prompt by actually putting the contents of what we pass in through to invoke in here, and then it's going to pipe that stringified, string formatted prompt to our model. Model will have invoke called on it as well, because model is also runnable. And then the response from our model will eventually get piped to our output parser when we define that, and then after all that, it'll get returned to our response variable. Let's quickly go over what our prompt is. And this took me a while to kind of get perfect, so there are a few important steps or pieces. I originally started and I was saying what most people say when they try and summarize something, which is saying write a summary of this. But I found that it didn't give great outputs if you say write a summary, because a summary, you wouldn't be reading a paper and you want to summarize it. You want to get key details from that paper. So if you summarize and then it says, the paper did this, but it wouldn't give me details. So when I changed it to say take notes, then it's replicating what it sees on the internet more, which is notes on papers or notes on XYZ, and they're more detailed and they contain more experts from that paper. So take notes is following scientific paper. This is a technical paper outlining a computer science technique. If you want to use this chain for something else, you obviously got to go refactor this prompt. And then we say the goal is to be able to create a complete understanding of this paper without reading or after reading all the notes. And then we give it some rules. So include specific quotes and details inside your notes. Respond with as many notes as it might take to cover the entire paper. Go into as much detail as you can while keeping each note on a very specific part of the paper. These are all important. We don't want it to take like 2 notes on, the first part and the end of the paper. We want it to, take notes on the entire paper, and we want it to go into detail. We don't really care if these notes are long, because they'll still, most of the time, unless you give it a really short paper, then it might give you more notes than the actual length of the paper. But if it's a long paper like the one we're demoing, which is 18 pages, we want it to go into detail, because it might only give us 5 pages total, and that's a lot better than reading 18 pages. Include notes about the results of any experiments, that the paper describes. This is important because before I had this, I tried getting it to take notes, and it wouldn't always include what the paper's findings were. It'd say, okay, this is what they're talking about. They're referencing these techniques, and that's it. And if you're reading a paper, you want to know what their outcome was. So this is very important. Include notes about any steps to reproduce the results of the experiments. I tested on one paper. It was the violation of expectations with cognitive metaprompting. And essentially that was a prompting technique on a series of LLM calls that is you're able to use that and get better details and notes about a certain conversation or history. And using this line, it would actually give GPT's notes it would take would be more details, and it would be easier to replicate the paper without just having an idea of what they did. With this, we can actually see how to reproduce what the paper outlined. And then do not respond with notes like the author discussed how well XYZ works. GPT-4 and I'm sure many other LLMs have a tendency to not really give you details. It's kind of what we touched on up here, but instead say this is what they were talking, not say this is what they were talking about, but say they spoke about this. So we don't want it to be general. We want it to be more fine-grained. So instead, explain what XYZ is and how it works. Respond with a JSON array, and then we kind of give some hints about the schema we defined up here. So JSON array, 2 keys, note, page numbers. That's our note and page numbers. And then give it a little better description about what each key should be. And then I had this line at the end. You can use different ending sentences. This is just one I read in a paper a while ago, which said, if you speak to GPT like a human, you tell it does it work step by step, take a deep breath, really slow down and think about it, then it does get better results, because it's mimicking what it's seen online. And I'm sure there's lots of content online where it's humans talking to other humans, and they say slow down, really think about this before you finish it. So it tends to get better results if you include stuff like that. All right, so once we define our notes, we've piped our notes through to our model. The last step for the LM call is to define an output parser. So since we're using LangChain, it's going to return the output from OpenAI in a type called a base message chunk. And inside of there are going to be some arguments, and from there we can extract our function call arguments, which is essentially what this is. It's reading the paper, and it's saying here's a function I can call by passing in these notes, but they're going to get returned as strings, so we got to do a little bit of parsing. So let's say const, let's call it output parser equals, and then output is base message chunk, and then from there we're going to define our schema after this. Yeah, we can go and implement it. So first we're going to want to make sure that they're actually the model did call tools. So const tool calls equals output dot additional quargs dot tool calls. And then if this is if this can be undefined. So if tool calls is false, or tool calls dot length equals 0, we're going to throw, because then the model didn't actually work. So throw new error, no tool calls. But if it did work, we can extract everything. So we can do const notes equals, and then we can map over our tool calls. So map tool call, or let's call it a call. And then from here we can say const note equals call dot function dot arguments. And these are the arguments that this tool called, and these will conform to this spec that we listed here. So it's going to have a notes object with a note and a page numbers. But this is type string because it's going to return from OpenAI, so we're going to have to parse it with a JSON.parse. And then we'll actually be able to do that because it's going to be an object with note nested. So then we can just return note. And let's actually go and define our type. So it's going to be type archive paper note. And that's going to be note string. Page numbers is an array of numbers. This looks right. And it's going to be returning an array. So now that we have this, it's going to be type any, so we can quickly just define it there, and then TypeScript will agree because it was typed any before, and then we can return it. And once that's done, we can export this to use it inside of our main function, and then we can pipe a response from our model through to our output parser. And now you can see that our chain is a runnable, which takes in any, and the response type is an array of our notes. So when we actually call invoke and we pass in the paper as documents as string, our response is going to be an array of these notes. And for this, we can just return our response. Let's also go and export our type so we can make sure this never changes. So it's going to be a promise of an array. Come on. Array of archive notes. And let's import this. And finally, right beneath here, we can remove these. Say const note, or actually we'll use those. And we'll just say const notes equals await, generate notes, pass in our documents. And then we'll just replace this so we can see the notes it took and how many notes it generated. And now we can go back to our terminal. And if we rerun, it'll take a second, it'll take 130 seconds to generate that, and then it's actually going to generate the notes, and it should log them and the amount of notes it generated. All right, so our chain finished running, and as we can see, it looks like it did not work, like the one undefined. So now we're going to go into LangSmith and see what actually went wrong. So I have the run here. We can see it was passed in the whole paper, went to our prompt template, and this output looks to be about right. Passed into OpenAI, tool calls, function, arguments, notes is an array, and each element has a note. So where did this go wrong? This gets passed to our, this runnable lambda is our output parser. So we can see we got tool calls, function, arguments, parse that, notes, and then each note is an element. So if we go back to the code, let's go to our output parser. We have the output. Looks like it went right to tool calls. So what we should have done, I guess, is const tool calls equals output dot. That doesn't exist. Okay, so definitely should be this. And we called tool calls. And the input was tool calls. So I guess let's just try it again. But console log exactly what we're getting passed in. So console.log output. And to make this development a little bit easier off camera, I'm going to stop reading it and parsing it each time because that takes, as we saw before, about 2 minutes. I'm just going to have it read from an existing PDF we have. So I will resume once I've done that. All right, so came back. Essentially what I did is, I took all of this stuff. We read the documents. I then wrote a file here. And then when I need it, I would read the file and send it to generate notes. And that way we didn't have to worry about actually using unstructured every single time. That would take a while. And while I did that, I called generate notes. I then logged the output and logged tool calls. And if we look at the output, we see output has additional kwargs, tool calls with an object. So we know that that is right. Output, additional kwargs, tool calls. And then here we're calling tool calls dot map. So we get to this first object. And then we parse call dot function dot arguments. So call, which is this first object, dot function dot arguments. But we're trying to do object destructuring for a note key. As we can see here, it's notes. So if we swap this out, then it actually does work. Let's rerun it and see what the output is. All right, so when we change it to notes, we can see that it clearly worked. So we got our after notes log, and we have our array, and it's a 2D array, which means that we forgot to call flat on this, but we know that'll fix it, so we don't need to run it again. And a length of 1, but it's because the array with all the elements are nested. If we look at this, the notes are actually pretty high quality. So it introduces a paper called Gorilla, fine-tuning llama-based model designed to surpass GPT-4 and writing API calls, combined with document retriever. It adapts to test time, blah, blah, blah. And yeah, so we will actually be able to read these notes in more detail when we write the front end. But now that we know that this is finished and working, we can go and bring this all back. We don't really care about this read file anymore. And swap that out. We can get rid of this JSON parse, and then we're done. So we're done with this. The next step, we're going to want to save this all to a database. We're going to want to save the generated notes, and we're also going to want to save the documents we wrote for our retrieval at the next step. For that, we're going to use Supabase. So when we come back, you'll be able to find a SQL command to run, which will write 2 tables. It's going to be one for our documents and then one for our notes. And from there, we're going to save those notes and documents, send it back to the front end. After we do the Supabase database, we're going to write a small Express API server. And then that way, these notes will persist. So if you're hosting the site and you refresh the page, it won't just be in state. You can actually go and refetch those notes. Also because these API calls are, they're not expensive, but they're not cheap. You don't want to be doing them every time you reload the page. So it's going to be nice to persist them. And then you can, reference your notes in these papers later. All right, so to set up our database, you're going to want to go to Supabase. You can create a project. It's fairly simple. They got great instructions on that. And once you've created your project, it'll take a few minutes to initialize. And when it's done, you'll see this. It's been deployed in your own instance. You're going to want to go to the SQL Editor tab. From here, you can go back to the repos README. Inside the README, there is a set of SQL commands, which you can copy and paste in. And what these commands are doing is they're creating 3 database tables and a function. To start it from the top, we see we're creating an extension vector. This vector allows us to store embeddings in the vector embedding column type instead of just putting it in like a 2D number array or something else. It's using PG vector, which is a Postgres vector extension. And then it creates the first paper, or the first table, archive papers. It's got an ID, created that with timestamp, and then a column for paper, which is the full stringified PDF. Archive URL, which is the URL of the paper. Notes, which are the notes we've generated in our archive notes papers type. And the name, which is the name of the paper that the user submitted. The second table is archive embeddings. These are actually going to store our paper chunks, our embeddings, and allow us, and any optional metadata, which we will use later, and it'll allow us to query this more efficiently. So ID, created at, content. This is very important that you keep these column names the same, content and embedding, because the LangChain Supabase vector store class requires this if we don't want to override it. So make sure you have content, embedding, and metadata. And the third table is archive question answering. These are going to store our questions, our answers, our context, and our follow-up questions for when we eventually do implement the web UI and users can ask questions. We don't want to just lose those, so we'll store them in the database. And finally, we create this function called match documents. This function is what the LangChain Supabase embeddings vector store class will use to actually perform semantic search on our database. It's going to call this match documents function, and it'll search up any columns or any rows in our archive embeddings table that match. And as you can see, we are saving on there, and here's our embeddings function. So if you copy and paste this and you run it, you'll see success, no rows returned. And if you go to our table editor, you'll see we have 3 database tables. You're gonna get this warning, you're allowing anonymous access to your table. If it's a private app that you're only gonna run locally and you're not gonna post this anywhere, then this is probably fine. If you are gonna go to production or publish your app to anyone online, you're gonna wanna add rules. For this video, that's out of the scope, so we're not gonna do that. We're gonna allow anyone to access, but these definitely are a must if you're going into production. Once you've generated your Supabase tables and your project has initialized, you're going to want to go into the API package.json, and you can see if you're using the template from my GitHub, I have a gen Supabase TypeScript. And essentially what this is doing is it's creating a file called db.ts inside of a generated directory, and then it's running the Supabase CLI command, Supabase gen types TypeScript schema public, pointing it to the file we want to generate in, and project ID. You're going to replace this with your project ID. This is very simple to access. It's in the URL of your project. So paste that in. And then if we go back to our terminal, we can run yarn build. This is going to build the API and the web. And in doing so, we see that our build command, our API, generates our types. And this is important because the types it generates, we're going to be able to reference those later when we actually write our database class, so we can have typed inputs and outputs. And without this, then everything would be any typed, and we don't really want that. So if we run yarn build, we can see it's building, and it built. And then if we go and navigate to this file, we see it generated all of this nice schema. And later we can go and import database. We can pass that in when we're initializing our client, and that way Supabase has everything nice and typed. We're going to want to export a new class from here. Essentially what this class is going to handle, it's going to handle writing to our database. It's going to handle embedding and writing our embeddings, any GET requests we want to make, and really everything that involves our database. So export class, let's call it Supabase database. And then we're going to want to have an initial static method called from, we'll call it static from documents. So static async from documents. And this will take in an array of documents, and it's going to return an instance of our class. All right, so inside this static class method, we're going to want to perform 2 checks first, which is getting our environment variables. So const private key equals process.env.supabase private, or whatever you defined it as. And then we also need the Supabase URL, or our database URL, const Supabase URL, and I got that right. And then we're gonna have 2 checks. If they're not there, then we're gonna want to throw, because those are obviously required. And the next step, we're gonna create a Supabase client. So thank you, Copilot. We can import this. And then what we did before was when we actually generated this database type, it created this called database, and we can pass this in as a generic. And that's going to let our client know, what return types our GET requests are going to return, and some other goodies like that. And from here, we're going to want to instantiate a vector store, and with that, we're going to use LangChain. So we're going to do const vector store equals, and then we're going to use this Supabase vector store from LangChain. So await Supabase vector store. We're going to follow the same. I guess I copied LangChain's API schema. So from documents, let's make sure this is imported. And this takes in a few arguments. So the first step is going to be documents. The next step is not going to be Supabase. It's going to be our OpenAI embeddings. So new OpenAI embeddings. That's wrong. Spelled that wrong. OpenAI embeddings. There we go. And the final step is going to be our database config. So we can pass in our Supabase client. It's called client, and we'll assign that to Supabase, and then our table name that we want to actually store the embeddings on, which luckily we generated that here. So our archive embeddings table, and we can import this. And then the final step is going to be that function. We named it match documents, and we ran our SQL command, and that's how we're actually going to match the documents using this semantic search. So query name match documents. You could, define this as a constant, but this is the only place we're going to use it, so I don't think it's really necessary. This is saying it's not assignable. Document is not assignable to document, and that's because this, I guess, is an actual node type, or I guess that's a React type. But what we want is the LangChain type. So from LangChain/document. And then this is no longer going to throw. And in order to, this is also wrong because we want to be able to have access to our Supabase client and our vector store and other methods. So we're going to define our vector store. It's going to be an instance of Supabase vector store. And then our Supabase client, we'll just name it client. It's going to be an instance of, or we'll just copy this, so our Supabase client, which we can import. And then we're defining our database type, our database schema public, and I didn't even really care about that. So then we need our constructor to actually assign these class properties. So constructor, we need to take in two inputs, which is going to be client, and that's the same type as that, and vector store. And then there you go. Thank you, Copilot. It's going to assign our class properties from the inputs. And finally, we can return a new this and pass those in. And now this is all happy. So now when we actually want to instantiate a new vector store, we'll call Supabase vector store from documents. We'll pass in our documents, and it'll return a new instance of the class. And later on, we will write some methods for reading from our table, writing to our table, adding embeddings, retrieving embeddings, and so forth. All right, so the first method we want to add is for adding our paper to the database. So we'll define a new async method, and we'll call it add paper. And this is going to take a few arguments. It's going to take the paper URL. It's going to take the name of the paper. It's going to take the full paper text. It's going to take our notes, and that's it. So let's add these types. Maybe Copilot will get it for us. Let's see what it recommended. Okay, so it's recommended paper, URL string, name string, paper string, and notes is string. That's almost right. We're gonna have to replace that with our archive notes data type. And then it's gonna try and call this .client from archive papers. Guess that correctly, but we're gonna have to, or we will reassign that to use our constant. And then it's gonna call insert. We're not gonna use this array. We're just gonna pass it. We're gonna pass in this object. We don't need to assign an array or an ID. Yeah, so this is mostly right. We got to do a little bit of cleanup. So this is going to be archive paper note. We only need error, or I guess we'll get data for now just to make sure our insertion actually worked. Let's reassign this to be archive papers table. Thank you. We don't need to pass it in as an array. We don't want to be assigning our ID because that was auto-generated as we saw in the SQL command. So paper URL, name, paper, notes. And then we're going to call select, which will actually populate this this data object, and that way we can verify that our data was generated. So if we go back to our index file, and at the very bottom here, we instantiate our database. So let's say const database equals await. Let's import this, and then from documents, one thing which you'll probably want to do later is add a check which says which looks up this paper URL in the database, and if it finds it, we'll add another method that will allow you to instantiate your database from an existing index. You don't have to do all this every time. But for this first time, it's got to be from documents, and you're probably going to want to add a check saying if this paper exists, don't perform all these computations because that's going to be too expensive. But for now, it obviously doesn't exist yet, nothing's in the database. And we can call await database.add paper, got that right. And then we can pass in our paper URL, our name, our paper, and our documents. Let's format this. Format documents as string, just to satisfy these types, and then we're done. So we should be able to run this, and then let's not return it. We don't need to do that. We can just console log data, and that should allow us to verify that our paper was saved. So we're going to want to get rid of this just for this test case. We don't need to invert. We are going to want to generate notes, but for that, we will just read this same document file. So we're going to say const docs equals await read file close pdf slash document.json. Let's add that type df8, and then we're going to want to parse these. So documents JSON parse, generate our notes, and then we're going to instantiate our database and add our paper with all of this. So if we go back to our command line, let's make sure we're not missing anything first. Looks good. And we run this. Then by the time this finishes, we should have all of our first table row inserted. And from there, we'll be able to retrieve, return, and persist our generated data. Okay, so while that ran, I realized I made one mistake, and I tried to assign paper URL when that was not a column and needs to be archived paper URL. So I swapped that, it worked, saved, and we can see we've saved all these notes. Notes saved beautifully. And then the next step, we're going to actually want to add our embeddings. So let's go back here. We can copy this because we're going to want to wrap into promise.all as they don't rely on each other. So we'll say await promise all to an array. We'll do this first one, and then we can call await database dot vector store dot add documents. And this is a method provided by LangChain where we can just pass in our documents, some options if we want to do that, and it will embed using the OpenAI embeddings we passed in here, and then it'll actually insert the embeddings and the content into our database. So once we call that, we promise.all it. We don't need these awaits, and then this method will be finished, and we can return the notes that we've generated. And when we set up our Express server, we will be able to call all of this. It'll read our paper, parse out our notes or our documents, generate notes, save everything in the database, and send back our notes that we can then go use in the client. All right, sorry about that. My recording was just interrupted, so it's a few hours later. But now that we've implemented our main function, we can go ahead and write our server.ts file for our Express server. So create a new file, server.ts, and we're going to create a function. We'll call it main. So function main takes no arguments, and we're going to also import Express from Express and do a couple things. So first, we're going to get our app variable. So const app equals Express. This sounds good. We also want to define our port, so const port equals process.port or 3000. Actually, we're going to make this 8000 because 3000 will conflict with our front end. For this index root, we're going to make this a health check. So add a comment, we'll say health check with a space. And this is just going to response.send 200 or response.status 200 send okay. And then app.listen at our port, and we should get listening on port 3000 when we start. So let's go to our package.json, and we're going to update our start script to start server.ts. And now if we run yarn start, it did not work. which is not what we want, and that makes sense. It's because forgot to run our function. So if we start it now, we see listening on port 3000, which also should be port. So port, and let's change this to template string. Boom, perfect. Now we can define a route. We're gonna make it a post endpoint. Post, and it's going to be, we'll just call it take notes. This is not going to be health check. We're going to want to extract some data from the request. So const, what do we want? We want the paper URL, so paper URL, name, and pages to delete from request body. That looks like exactly what we want. Make sure this is exported. We'll rename this to take notes. So now we can import our take notes. We'll say const notes equals await take notes. And we can import this. We also need to make this async. And then once this function runs, we'll just say return or response.status 200.send notes and return, so that this doesn't do anything after that. And now we can open up Insomnia or Postman, and you can actually check and validate that your endpoint works. All right, so open up Insomnia or Postman or whatever you use. We're gonna add localhost 8000, and then our URL is take notes. And we need to add a JSON body that's going to contain a paper URL, and we'll add this later. It's going to contain a name, add this later, and we are not going to specify pages to delete right now. So let's go back and get our paper URL. So archive.org, and we're going to want to put that in there, put the name in, run it, and make sure everything works end to end. All right, so now that we have our paper URL in our copy paste, we paste it in. I'm just going to go and copy the name of the paper from archive. Not going to do anything special, and we'll send that in there. And when we send this in, or when we start our server and then send it in, it should take us, it should error out. Okay, cannot destructure property paper URL of request.body as it is undefined. Interesting. Okay, so let's debug this. Request.body is undefined. If we console log request, we got to restart our server, and we send it in. Then we're going to see, did we find archive? See if that was found anywhere. Doesn't look like it. Nowhere. Okay, so we're not actually passing this in properly, which is interesting. So, all right, so we're back. I investigated the error. Turns out it was, it must have been something with my Postman request, because I just created a new request through take notes edit, and it worked. Did present another error though. I had forgotten to pass in the actual PDF URL, so it was trying to save a PDF which was not valid and read it from Unstructured. But here you go. Now that we fixed all of that, we pass in the proper URL and make this request. So we can see we're at PDF. We're going to send it, and it's loading. And this looks good because it's going to take a while. So yeah, I'm going to pause this, and when this finishes running, we will resume. Alrighty, so this took a second, but we can see it worked, gave us our notes, and it returned them in the format we asked for. So the next step, we're going to want to actually create our question answering directory, and to do that, we're going to refactor this a little bit. So we're going to make a new folder, we'll call it QA, and another folder, and we'll call it notes. And then we're going to, inside of here, make an index.ts, and copy over all the contents from here. And then we're going to just drag and drop that in there. And this is going to take a second. Okay. And it should have fixed all of our imports. Looks like so. We can delete all of that too, and we got to refactor where that gets that from. And then inside QA, we can also create an index.ts file, and we're also going to need a prompt.ts file. So we're going to create a function, and it's going to have to take in a couple things. The question as a string, the name of the paper. We're going to use that as metadata when we filter in our database for the embeddings. And yeah, I think that should be good for now. So async QA on paper, and we're going to take in that question string and name string. And this is going to, yeah. Okay, so now we need to make an update to our database. Right now we only have a from documents method, but obviously for QA, we are not going to need to add documents. So we're going to want to add a from existing index method. So from index, it's going to take in no arguments, perform essentially all of the same checks as here, but it's going to call the from existing index method here as well. And this is only going to take in the embeddings and the dbconfig. So we can swap that out for that, and boom, now we have our from existing index. Now that we have this, we can also go and refactor this method and bump this up here and say from existing index, and boom, now we aren't embedding our documents and doing the from documents every single time. So we're going to want to copy that over here because we're also going to need this database. Alright, so the first step here, obviously we got to import that, and then we're going to want to retrieve our documents. So we're going to say const doc documents equals await database.vectorstore.similarity search. Oops, that's not right. But similarity search, and this is going to take in 3 arguments. So the query, k, which is the number of documents we want returned, and any metadata filtering. So obviously question, and then we're going to get 5 documents. We'll do more. We'll do 8 documents, and this is something where you're probably going to want to play around with it. 5 to 10 has worked well for me in the past, but it really depends on you know what kind of papers you're analyzing and your chunk size and whatnot. And then our metadata is going to be name. Should just match the name. And this is something we can verify by actually looking at our Supabase embeddings and inspecting one of the rows. I'm looking at the metadata. So if I copy over all of this, so it actually looks like I made a mistake in the last, the other database step where we're actually inserting these embeddings. We want to add metadata where the name, where we're adding in the metadata name should include the name of the paper that these are submitted, or the paper URL. You know, it's some sort of identifier so that you can reference it later. So if we go back here, we're going to want to add documents. These already contain our other metadata. So we're going to want to add a loop, which is going to say const new docs equals documents.map doc. And then we're going to want to return pretty much the entire doc, and then metadata. And we'll use the URL. That's probably a little bit more foolproof. So doc.metadata, and then URL is going to be paper URL. And this is going to be, let's see, document, but it's an array. And it should be happy with that. And then we're going to save these documents. This shouldn't change, it's just the page content, but this is actually what we care about. Because now, when we go and query it, we can use, we'll swap that out for the URL, so paper URL, and then we can query by that. So then this similarity search is only going to perform that search over documents where the metadata has this field, and that way we can have tons of different papers indexed but our similarity search will only be on the relevant documents that we care about. All right, so the next step, we're going to want to actually include all of the notes that GPT took originally in this API call. So we'll go back to our database and we'll add a new method and we'll call it async get paper. We'll take in the URL, that'll be our identifier, and it's not going to that. We're going to want to return database, and we can get the type from here. So database, public, tables, archive papers, row. So database, was this lowercase? Yes, so database, public, and then tables, archive papers, finally row. And that's gonna be our response type. So now const data or error equals await this dot client dot from archive papers table select equals the archive URL. That's exactly what we want. We'll add a check that says if error is true, and we'll add a console.error, just letting us know this is where it happened. So error getting paper from database, and then we'll rethrow that error. And if it's not, then we only want one of the papers in the database. So if this is true or data is false, and if it's not, then we're going to return data bracket 0. And then we should be able to call this in here and say const notes equals await database.getPaper and then paper URL. And these notes, as we can see, it's that JSON schema, but we know that it's going to be our archive notes. And then the next step, we're going to want to actually construct our prompt, construct our output parser, our tool types, and make those requests. All right, so for our tool schema and prompt, it's going to be the same deal as before. I'm not going to want to type this all out. We can copy and paste it in, but we're going to go over everything. So we have a chat prompt template like we had before, and we have this from OpenAI just to find the type. So import that OpenAI as that from OpenAI. So what this prompt is doing is we're telling it, here are the notes you've taken, here are the relevant documents from our semantic search, and here's the human's question. And we're trying to, tell this GPT to act like a professor who knows its stuff and, can give us better notes because, as we know, GPT is trained on data it's seen online, and it's likely seen better data, better question answering from these academic settings. And then our tool schema, it's going to be an object with the answer and then follow-up questions. And we're also asking GPT to suggest follow-up questions based on the question and answer. So now if we go back here, we're going to want to define a new function, async function QA on paper, and we'll take the question. That's good. String, but we also want the documents, array of documents, nope. And we're gonna have to add this type from LangChain as well. So import document, and that's spelled wrong, but we can do this. Document, and then finally we want the notes. So it's going to be notes, and we'll type that as the array of archive paper note. And then to do implement for now. And even though this is type JSON, this should hopefully work, and we hopefully don't have to cast it. We don't. Okay, we know it's archive paper URL, so we can just cast it as unknown as that, and then it's happy with all of this. So QA and paper, that's the same name, so we will rename this to, let's say, QA model, question answer on model. So now that we have this, we need to do a few things. We need to convert our documents into a string, using the same method as that we used before. we need to convert our notes into a string and then pipe through our prompt, our chat model, and our output parser, which we should do the output parser now. It's pretty much the exact same deal as our output parser for taking notes, but instead of going in and extracting one more level for notes, we can just return args right away. So it's answer, follow-up questions, answer, follow-up questions, get the tool call, error if it's missing, map over the tool calls, parse the arguments because they're a string, return it, flat in case it tried to return multiple arrays, and then return that. And then back in here, we can say const model equals new chat OpenAI. This will be the exact same as before, so model name equals GPT for 1106 preview, and temperature should be set to 0. And now if we, what is going on? Now we want to define our model with chain, so const model with tools, model.bind. This is exactly what we want. Is that the right name? Almost the right name. So we import this, and now we can construct our chain. So const chain equals our prompt, import that, dot pipe, model with tools, dot pipe, to our output parser, which was named answer output parser. And then we can invoke this. No, we got to import that. Well, before we invoke that, we have to convert our documents to string. So const documents as string equals format documents as string from LangChain, pass in our documents. Notes, we're going to const notes as string, and we're just going to map over these notes. So notes.map note, and then note.note, and join them with a new line. And now we can say const response equals chain.invoke. Here's the paper, which is the documents as string. Here are the notes, and here's our question. Let's verify that's going to work. So we want question, we want relevant documents, not paper, and notes. So notes, relevant documents, and question. And then we can see this is the right type, and we're going to want to go ahead and return this. So return response. Now down here, why does it not like that? Let's ignore that for, oh, it's because we renamed the function. So QA model. And now return QA model. And yeah, this is exactly what we want. So we can see this return type is that. And now we can export this to our server and create a new route for it. So import QA and paper from QA index.ts. Go back here, could actually export this. And now this is happy. And we can create a new post route. We'll just name it QA. And then we're going to use this function, but we only need the question and the paper URL. So keep question paper URL and then question, and remove the others. We'll rename this to QA and return that. And now if we go back to our server and we restart it and go to Insomnia, got our paper URL. Well, we actually, since we changed how we do our metadata, we have to go in and reload this so that the metadata is what we want, and we can actually search for the semantic search. Okay, so before we actually go and create our express route, I realized we forgot one thing. Const answer and questions equals await. And then we want to actually save this to our database so we don't lose them if the user reloads the page, or if you lose that state. So go back to database and we'll create a new method called async save QA. This is going to take in a few things. It's going to take in the original question string. It's going to take in the answer string. It's going to take in the context used string, and it's going to take in the follow-up questions follow-up questions, which is an array of strings. And this is going to act very similar to our add paper. So we can this.client.from archive QA table, and then it's going to insert not that. So our archive QA table has, let's make sure we're adding the right types. Okay, so question, answer, context, and follow-up questions. Beautiful. And if this works, then it should save to our database, and we should be able to retrieve it in the future. So we go back here, and then we say await database.saveqa, and then since this can technically be an array, we're allowing GPT to return multiple. We have to map over it. So dot map, and we can promise dot all this as well, QA, and then await database dot save QA. We don't need that await though, because we can make it inline, just like that. And this takes in question, answer, context, follow up. So question, answer is going to be QA dot answer. Context is going to be our documents. So we will do the same documents format as documents as string. So for the context, because that requires documents to be a string. And then the final follow-up questions are QA.follow-up questions. Should be happy with that. We got to wrap this in a promise.all. Await promise.all and make this async. And then our notes are actually going to get saved. And finally, we can return them here. And while you're gone, I also cleared out my database to make sure there were no conflicts. So let's restart our server. Let's go back here. We're going to want to take notes on this paper, send it off. When this is done, we can then go back and perform QA. And we'll ask a good question and see if it's able to give us an interesting response. All right, so that took a long while, but if we go into our embeddings and we inspect one, we can see that the URL now contains our archive URL. So we can swap that to be QA, keep the paper URL, and swap the question to be how does the paper manage the AST? Pretty general question. I'm not really expecting something too technical back from this, but it's related to the paper. And it should give us something that's okay. So if we send that request, this will probably also take many seconds. When it gets back with the answer and the follow-up questions, we'll resume. We can read over those. All right, so that was much quicker than the other ones because it's not actually indexing a full, 18-page paper. So we see the answer is the paper introduces an abstract syntax tree, subtree matching technique to manage functional correctness of generated API calls. This method involves parsing the generated code into an AST and then finding a subtree within the AST that matches the API call of interest. By doing this, the paper can verify the functional equivalence of the API calls, ensuring that the generated code is not only syntactically correct, but also functionally appropriate for the task at hand. And if you've read this paper, you do know that that is overall related to what the paper is talking about. They're essentially, how to use LLMs to mock API calls, and how do you tell that those are good. So the follow-up questions are, can you explain in more detail how the AST subtree matching technique works? How does the AST subtree matching contribute to reducing hallucinations in language models? And what are the limitations, if any, of using AST subtree matching for evaluating API call correctness? These are all pretty good follow-up questions, and I would be interested to hear the answer from a few of them, but in the interest of time, I think we're going to cut it there. All right, for the client portion of this, we're going to use ShadCN. They provide some nice pre-built components for our form, our button, our inputs, the other components we'll need to use. You're going to want to find the Next.js section under installation. We're going to set this up. You don't need to run this command because the monorepo structure I've provided already did this for the web directory, so we can skip right to step 2. Run the CLI. Want to make sure you're in the web directory, and then you can run this command. We're going to say yes to TypeScript, default style, default. Our global CSS file is located in source /styles plural /globals plural.css. We'll use CSS variables. That's good too. That's good. That's good. And we're not using React Server components. Yes. And we let install dependencies. Once we've done that, we can go back and you can see it installed a few things. It added this utils file, components.json. This, when we actually install components, they'll go here, or the config and the actual components will live here. And to start, we're going to install the form component. So find form, scroll down, and copy this command for the installation. Go back to your terminal, paste that in, let it load. What this is going to do, it's going to install some dependencies. It's going to actually pull in some code that will live in here. We can see it's already done that. And it pulled in the button and label for us as well, which is nice because we were going to need those. And next, we're going to want the collapsible component. So we can run this command. And while we're at it, we also know we're going to need the text area component, so we'll copy this as well. And we can run it in one line. So installing collapsible done, and text area is done as well. If we go back, we can see we have collapsible and text area. All right, so to start developing our web app, we're going to want to run yarn dev just so we can see our changes as we update. You can navigate to localhost 3000, and we can see that our page says not implemented, which makes sense because that's what we have. And we're going to start the overall structure of our front end. We're going to have two forms, one for submitting new papers to get notes taken, to have all of their content embedded, and a second for asking questions and answers over that paper. So we're going to want to have two divs. We're going to have them in a row, and we're only going to do just desktop styling right now. If you want, you can update it for mobile later, but for now, desktop will work. And we're going to use Tailwind. So class name equals flex row, and we'll add a gap of 5 should be good. And then inside of here, we're going to create two more divs. Div, and this will be our, this will be our add paper, and this will be our QA on paper. Inside here, we're going to want to have another flex box, but we're going to put everything in a column because it's going to be a form. So class name equals flex call, and we'll add another gap of 2. Then we also want to have a border on this, so border 1 pixel, and we'll give it a background of, let's say, gray 400. So BG or border dash gray 400, and we'll give it a slight rounding. We'll do medium. And then for our form, it would actually be easier if we just go to shadcn, go to their components, find the form, form, and we can just copy what they have in here for the example. So form field, the form item, or actually we can go down here for a more complete form. So let's copy all of this, bring it back, and we'll paste that inside here. You need to add these imports, so add all missing imports. Means we have the button from our components, all of our forms from our components, input, do not want it from post CSS, and form from React hook form, don't want that from there either, so we can swap that out and delete these two. And then for our input, where's our input? Oh, we never added input. All right, so we need to install input by finding it in shadcn, going back to our terminal. Let's open up a new window, paste it in, done. And now if we go and reload our page, get VS Code's cache updated, and try and input this, we'll see we have it from components. Next, we got to go back to our form, and we need some extra logic around the form. So did they install Zod for us? Zod, yep, they did. So we need to create a form schema. So install star as Zod from Zod. We can do that. That'll work. And then we need our form schema. We will call this submit paper form schema. And this is going to have a paper URL, which is a string. Don't need any of that. We need a name, which is also going to be a string. And what's the last one? Pages to delete. And is this right? An array of numbers. That's correct. And then we also need to make this .optional. So once we have our schema, we go back. What's next? We need to define our form using the use form hook from React hook form. So we can import that, come back, define our form, go up, and we can also call this submit paper form. And if we swap out our form schema, gotta add Zod resolver as well. Is that the right import? Yes. Replace our form schema there as well. And we're not gonna have any default values. All right, so now we have our form. Let's swap that out there, swap that out, swap that out. We are going to update this to have different form fields. So we're gonna have 2 main form fields, one for the paper URL, and we're going to call this paper URL placeholder. We can go and actually use the placeholder from the original paper we used. So Arxiv, this is it. So we'll get the PDF URL, and this can be our placeholder. And then form description, the URL to the PDF paper you want to submit. Paper URL, placeholder, description. Next, we're going to do name. So we got to make that name, change that to name, give it a capital, and we can also use this as the default name, Gorilla. And description, the name of the paper. And now if we go back to our server, see onSubmit is not defined. That makes sense. We need an onSubmit handler, so we'll just copy this without any functionality yet. Go up here, paste it in, and we're gonna actually change the name so it's gonna flip to with our other onSubmit to on paper submit. Add in the right form schema, and this is going to infer the right type. So on paper submit, paste that there. We can delete that for now, and we'll prefix this with an underscore so we can delete that. And now if we go to our page, it should have loaded. Yes, but we don't want this to be all the way to the left, and we want some padding around the edges. So we'll go back here. Let's indent this a little bit. I gotta do that. Beautiful. One more. And we'll add a padding of, let's say 2. How does that look? That's pretty good. And then here we should do mx-auto, and hopefully this brings it to the middle. No, it didn't. All right, we will touch that later. For now, we're going to want to get the last form field in and the submit. And the last is going to be our pages to delete. Since this is optional, we're going to wrap it in a collapsible. So we can find collapsible, go down to their example, copy that. We'll put it beneath our last form field, but above the submit. Fix that. Let's add in our imports. Beautiful, collapsible trigger. So now if we look here, say, can I use this in my project? We also want to have, here they have this nice little icon. So where is their icon? We want chevron up, down. Let's see, did they install this for us? we go to package.json, search for that, yes they did. So we can do chevrons up, down, plus. Where is the plus being used? Looks like, all right, we'll ignore that. Let's import this icon. So if we go back up here, let's put it there, and we can remove them when we don't need them anymore. Collapsible div, they had it saying start 3 repositories, and then trigger as child a button with this icon. So we can paste this in as the trigger, like so. Fix the imports. We'll call this toggle, span toggle. So if we go back here, we see now there's just this. We want to add some text as well, so we'll go p tag and we'll say delete pages question mark. All right, this formatting is a little bit off, so variant ghost width 9, we don't need that. Let's just delete this styling. And there we go, delete pages. We want to make one change this. Font light, that's better. And we'll make it normal. Yeah, before it was bold. And now when you click this, it opens this drop down. And instead of having this content right here, we can add another form field. And this time it'll be for the pages to delete. So pages to delete, and then we'll add 10, 11, 12 as the placeholder, and then the pages to delete from the paper. And if we go back, see delete pages, open it up, and here's our input. And then submit. We can go back and re-add this console.log, submit paper. We can remove this underscore as well since we're actually going to be using it now. And let's test to make sure this actually works. Give this a full width. And if we say that, and pages to delete, we shouldn't need to have it like that. So let's see, test 1, we don't need that either. Why did that delete? Okay, so that deleted because we forgot to change the control. Update this to be pages to delete, and now we can add that, and it doesn't add anything there. And if we hit submit, we see it expected an array and we received a string. Okay, so input placeholder on change event blur number undefined is not assignable to string number. Okay, so what we're going to do instead is change this to be string array, and then inside of our on submit we can convert it back to being a number. So that array, that error went away. Pages to delete, submit. Come on, is that the same error? Submit. There we go. No more error after our reload, and we can see it logged our values. And then if we want to submit some pages as well, expected array receive string. Definitely don't want to make our users have to punch in an array, so we'll just do some parsing after the fact. And if we reload here, add in our values again, and add in our page to delete and submit, we can see we got our paper URL, page to delete, and it's all nice there. Alrighty. So next what we need to do is add some regex after the fact that will actually verify this is a list of numbers that's comma separated, and it'll convert it into an array of numbers. Okay, so for converting our pages to delete to an array of strings, we'll create a little util function. We'll name it function process pages to delete. It's gonna be a string, and then const num array equals pages to delete dot split map parse int num. That looks beautiful. And this should throw if one of these are not a number. We're gonna want to trim this as well in case the user submits some extra spaces, and then we can return this. And if we verify the type signature, nice, and a number array, and let's type this just because we don't want anybody changes after the fact and returning the wrong type. So now we can get all of our values in the proper formats. We're also going to want to save the paper and the name, or I guess just the paper URL in state and the name, just to display to the user, and for when they ask questions, we'll actually know what paper they're referencing. So const, let's see, paper data, or we'll call it submitted paper data. Submitted paper data, and then change that to be set submitted paper data equals state, and we'll type out our archive paper notes, or we'll type out this type, and we can make it that type or undefined. So type submitted. Oh, actually, we can just use this. Well, no, that won't work because that's the wrong type. So yeah, we just make a type. So type submitted paper data equals, beautiful, exactly what we want. And then we can type this to be either this or undefined. And we got to add this import as well. Nice. So now once we've submitted, we can set our data values, and pages to delete can use our function. Nice. So if pages to delete is true, we're going to process, and if not, undefined, and this will work with our type. All right, next step, we're going to want to fetch our data from our API. So for now, we can write out our fetch request in our processing, and then we want to test it. We have to actually start our API. So const response equals fetch API / papers. And we're going to rename this to take notes, which will match our backend. And then method post body stringify our values. Nice. And then we can turn this into async. And we're going to want to do a .then res, and if res.ok is true, we can return that, and else, no, we don't need an else, just return null. So this is either going to be the type or any. And then inside of our API directory, we create a new file called takenotes.ts, and we can just copy what they have there, paste it in, and change this to make a fetch request to our actual backend. So const data equals await fetch, and then for now we can use localhost, but if you're in production, you're going to want to change this to probably an environment variable, which can change between your local, your staging, or your production URL. So for now, we'll just do const API URL equals http://localhost 8080, and it's just /take notes. And I want to make sure that's actually what we, yes, take notes. So API URL await fetch the URL, and then method post header updation JSON body. We can use the request dot body, and we don't need to stringify it again because export default async function. We don't need to stringify it again because we are already stringifying it here. So data, and then we'll do the exact same, if it's okay, null, if not, return null. And then we can say if data is true, return response.status 200.json data, and this 200 is what's going to set our okay to be null, or sorry, our okay to be truthy or not, and then else 400, and we'll just say error for now. All right, so let's go back to here. We can go out, we can do yarn start API. Now our API is started, listening on port 8080. One more thing we can do here, we can actually type out the data in our response. So we know that this is going to have that response type. And we want to just copy and paste that wherever it is. Delete that if it's not being used. Here we go, archive paper note. So we'll just copy this exact same type. Go here, replace that. It'll also export from here as well. And now here, or we have to count for our error, so name, and then we'll actually explicitly say it's error. And why don't you like that? Type error is not assignable to error. Okay, so that's not going to work. And we'll just say or undefined. If we get a response status 400, we know that's okay, or we know that's an error. So now that this is all working like that, we can set our response type to state as well. So const, we'll call it notes and set notes, and then we can use this type as well. It's actually not going to be singular. Instead, it's going to be an array, as we can see here. So we need to update this to be an array of notes. So array, archive paper notes, or undefined. Go back here. We can say an array of archive paper note, import it, or undefined, response, and then if response is true, const data equals await response. We need that here. So await this response, any, if response is true, then set notes response dot data. And one more time, double check. Beautiful. And then else, let's just throw so we can see the error. Throw new error, something went wrong. Taking notes. Boom. We should also probably console log this. So console.log response.data, just because we're not actually doing anything with this right now. So that's going to make it easier to see if our API worked. So we can go back to here. Let's copy this, paste it in. We can copy the name as well. Paste that in and delete pages. We need 10, 11, 12. Is that correct? Let's see. 10, 11, 12. Nice. 10, 11, 12. And now if this all works, we know that it should take about 2 to 3 minutes. And that's accounting for unstructured and the OpenAI response. And then we should get a console log with our notes. So submit. And boom, we already got an error. So that does make sense. Probably was not awaiting because that came back so quickly. But just to be sure, okay. So here's a problem in our API. Throw new error, exports back to value name, index. Okay, where is this coming from? Validators, export summary. So it's in our PDF document parsing. Let's verify that our types are all getting set properly. So if we go back here and we console log all of this, and we got to restart our API for this as well. Yeah, that gave us a nice error. Okay, let's go back. We can just reload, copy the name. We know we're gonna have to do 10, 11, 12. And we can copy this name. All right, and if we submit, then we go back here and we see paper URL. Alrighty, and this was getting passed in as a string. So what we're going to want to do is, let's see, is our data actually getting formatted properly? This is definitely going to be a number array or undefined. So what we should do here instead is, I guess, unparse our notes. So convert pages to delete back to array numbers. So const pages to delete array equals pages to delete, and then we can just copy over this exact same code because we can see from the type that it logged, it was just a string that's comma separated. So if we go back here, and we'll just put this right there. Whoops. Copy, paste. So it's going to be a string. We want it to return an array of numbers. And we'll just wrap this. We need to do the check. So or we'll just say if it's truthy, then process it, and else just do an array. We can actually just do undefined because it is optional. Undefined. Put that in. Put that through. And if we copy this one more time, console.log, just to verify it's all working, restart our API, go back to our web, reload, let's copy the name, paste it in, do 11, or sorry, we can just 10, 11, 12, copy the URL, paste, submit, and we can see that it logged an array. So while this loads, I'm going to pause the video, and when it finishes loading and hopefully logs our notes, we'll come back and we'll see what it logged. All right, so we're back. Our response turned undefined, but if we go to the network tab and inspect it, then we can see that our payload was right and our preview was this, which means we were trying to parse response.data when data did not in fact exist, and response would have done the trick. So if we go and we update our index TSX and just do date response, we know that'll work, and it will actually solve or save our notes. All right, so before our notes actually return, we can go and we can add a section beneath our two forms, or where our two forms will be, for displaying our notes. So we can say if notes.length, or if notes is true, and notes.length is greater than 0, we want to log a div, class name flex call, gap2, border 1 pixels. That looks good. We don't need a border for this though. There we go. And we'll say h2 notes and div flex call gap2 notes.map. Let's see, note, and to prefix, we'll make this a paragraph tag instead. And let's see, we'll make this class name equals, we'll default text body medium, and yeah, actually we don't need any styling for this. But what we are gonna want is update this, flex call, nope, want this to be a row with 1 gap, and we'll keep the padding. And then here, we're going to want to have another paragraph tag, but class name text dash small and text dash gray. And let's make it 600 to be a little bit in the background. And this is going to contain our note dot page numbers join comma, and we'll wrap this all in an array so people know that there's page numbers. You know what, actually I think Tim was right. We do want to have this in a column. We'll have this beneath gap 2 is probably right as well. But what we can do here is actually number our notes. So let's do the index of the array, and we'll do index, so it'll be 1. It's gonna start at 0. We gotta add 1, so it'll be 1, then the note, 2, the note. And what is it complaining about here? We have our opening, closing, opening, closing. Why aren't you happy? Div. We're missing a closing div. Okay, and that's gonna be for this one, so div. And that makes sense. We also need a key. And ideally, you don't want to be using index as your keys for arrays or mapping over arrays in React. You probably want something like an ID. So if what we should be doing, and if you're going to put this in production, you should be returning the generated database rows after you write it. So when you, all right, I'll just show you. So you take notes, you add papers to the database, and you should be, instead of just returning an error, you should also select them and return the data and return that. So then you can return your ID, your created at, and the notes, and that way you don't have to use an index as a key, and you can use the actual ID. And if you want to do other things with that data, you'll have the ID in the database, or you'll have the ID that matches the ID in the database on your client, and it's easier to manipulate and request that data there. But for now, this will work. We're only using this locally. And we can save this, go back to our front end. We see there's nothing there because we don't have any notes. And if we go and do this again, and we copy the name, done this a million times, and 10, 11, 12, make sure our API is running, yes, submit, and in a couple minutes, we'll come back, we'll see our data get logged, and our notes logged out there. All right, so we're back, we see it logged all of our notes, and our notes got logged here. This is not really what we want, so we should clean up our styling. We can see it's inside this div, and we defined it as a row when it should be another div here, where we can copy that, and then add another closing div there, and that will wrap our forms in a row, but we want our notes to be in a column. And if we go back, we'll see, there we go, our notes are in a column, and that's make it a little bit nicer. We'll set a max width to, let's say 600 pixels. How does that look? Much better. Next, we need to add the second form for question answering. We need to add a check in our backend, which will verify that our database does not already include a paper with this URL. And if it does, we can just return it right away, so we don't have to be embedding and taking notes on multiple papers. And then so add that, set up a form for our question answering, and add a component for actually logging our questions and answers and the follow-up questions, and add a way to easily click on the follow-up question button and have that follow-up question be sent to our API.
All right, so now that we have our paper URL and submitting a paper hooked up, we're going to want to set up our second form for actually asking questions and answers. So if we go here, we can pretty much just copy this whole div and then remove what we don't want. So copy that in, and then we know we're not going to need this collapsible, so we can drop this. We know we are only going to need one form field for the question the user wants to ask. So we're going to swap this to be question, and the question placeholder or description will be the question to ask about the paper, and the placeholder will be why is the sky blue? That's good. And then we're also going to need to create a new form schema. So we can just copy what we had before, and we will rename it to be question form schema, and swap out this key to only be question. Next, we can go and put it in here. That's not right. We need to go and create a new form first, actually. So copy paste that, rename it question form, swap out the schema type, copy that, and now we can go and swap these out. This name will obviously have to be question, and we need a new on submit. So on question submit, and then once again swap out the form schema. And for now, we will just comment this all out and console log what the values are that get submitted. Okay, let's take our form schema, pass it in there, and if we go back to our UI, we should see it looks like that. Let's do a little bit of housekeeping to make this prettier by going to this div, and we'll say margin X auto, and that moves it over. And let's move it down from the top a little bit, so margin top 3. There we go, that looks better. Yeah, and now we can test this out. Hello world, submit, and we see we get an object with a question of hello world. That looks pretty good. And the next, what we need to do is connect this to the API. So we can copy what we had here, or just uncomment this, swap this to be QA. It's going to be a post request. Our values will not just be this, because if we go to our server.ts, we see that QA requires the paper URL as well. So index.tsx, luckily here we're storing the submitted paper data in this object. So this contains the paper URL. So what we need to do is create a new values object, and we'll name it data. So const data equals values and paper URL, submitted paper to paper URL. But we should also add a check and say if this is false, throw new error, no paper submitted. So we know that this will be truthy, and we can swap out our stringified body to contain this data object. And then once that's done, we're going to want to make a new state variable called, we'll call it answers, and set answers. For now, we will not type this. We'll set our answers just like we set our notes. And last step, we need to duplicate this take notes inside of our client API. We'll rename it to QA to match our backend. And we swap that to be QA, post, API URL. This all looks right, except it's not going to be this type as we saw before. So if we look at QA, QA returns answer and follow-up questions as an array. So we can go and add this type. So we'll name it QA response, and it will be answer as a string and follow-up questions as a string of arrays as well, or an array string. That's going to be an array of this or undefined. This all looks good. Let's go and import this into our TSX file. So answers, set answers can either be basically the same as this, or not or, we can just swap out archive papers for response Q&A and import it. And that should all be good. So let's quickly add a JSX for our answers, just so when this works, we'll be able to see them. So we'll say answers is true and answers.length greater than 0. And then we can do, Copilot will probably suggest what we had before, so let's see what they suggested. So a div that's in a column, max width 600, just what we wanted. Answers instead of notes, map it over, and it'll be answer.answer. So this is saying the answer, and then the content. We're not going to want that. We're going to want this to be our instead of our page numbers, we want it to be our follow-up questions. So we will do answer.follow-up questions dot map follow-up, and then we can just copy this, and we need to give it a key. We'll just give it key equals the index as well. So index, key equals the index. Beautiful. And then instead of that, we need to put the follow-up, and let's wrap this all in a div, which is a columns div, last name, flex call, gap2, padding. That looks good, but we're not going to do follow-up questions there. Instead, we will put that let's format this right above. So we will have another just plain p tag, follow-up questions, boom. And now, if we hit this API, after we load a paper, we ask a question, then it should all work. I'm going to pause this video because this will take a minute, and when it comes back, we'll hopefully see our notes and our questions and answers all in the same spot. One quick thing we can do before we submit that again is go back to our notes section, and instead of always adding it to the database, we can first do a check, and we can say, or we can add a new method to our database saying find paper by URL. So async or get paper by URL, and we're just going to take in the paper URL string, and we're essentially just going to query the papers table. We're going to select one by the URL. If it's false, we're not going to want to throw error. We're just going to want to return null, or we will return the actual data. Actually, we already had a method, so that's nice. We don't need to redo it. We can just do get paper, and we're going to swap this to return null instead of throwing. Nice, and let's swap out this response type to be or null. So now we can call get paper inside of our notes. We can say const existing paper equals await database dot get paper URL, and then we can say if this is true, return existing paper dot notes, and we'll cast this as array of archive paper notes, and then our response type will be the same. And for good measure, let's type this response type just so we never accidentally return a type we don't want. There we go. So now, if the paper exists, we don't have to recompute our notes and our PDFs, and we can just return it, and it can be pretty quick. So if we go back here, our paper should already be in the database, so we can copy this all in just for good measure. 10, 11, 12. Let's go to our terminal, which I accidentally just killed the web for. Hopefully it comes back. We can go up one level and do yarn start API. That should start our API. Beautiful. Let's bring this away. And okay, it did reload our page. It's not the end of the world. Paste that in. Paste in our name. And 1, 2, 3, submit. And boom, we can see it returned instantly because it found our paper from the database. And now we can ask a question, and we will say, what are the results? Or we'll say, how does Gorilla manage the AST? And if we submit this, it should take a second, and when this comes back, I will respond with, I will resume this video with the different answers it gave us. Alright, it's back. Took a lot quicker than I thought it was going to be. It says Gorilla manages abstract syntax tree through methodology, blah, blah, blah. And there we go. So answer looks good. Only problem is our follow-up questions. Let's see what went wrong there. It just logged follow-up, and that makes sense because I didn't wrap this in a bracket. So this obviously won't reload. Oh, it did. Okay, there you go. So you see our follow-up questions. Can you explain in more detail and whatnot? And the last thing we should do is make this a little bit prettier. So let's wrap this in a div. We'll name it flex call, gap 5, margin x auto. That's good, but let's do this in a row instead, just so we have our answers and our notes side by side. So then if we copy and paste these inside this div, go back, and there you go. Looks a lot better. We've got our answers and our notes. Let's have it match up with the columns though. Just one little nit. Boom. Notes on one side, answers on the other side, questions, and adding a paper up here. And it all works pretty well. So yeah, if you want the finished code for this, it'll be in the GitHub linked below. Once again, the mono repo template which you can clone to follow along for this tutorial, will also be down below. And I appreciate everybody for sticking around this long. I hope you learned something, and I hope this site is useful for you for future papers and other content you want to read from Arxiv.